All right, welcome to problem solving lecture. This is our first lecture of the semester. And so really this is about getting used to solving mathematical problems. All right, identifying patterns and recognition, understanding the problem, reading the problem carefully. And so there's lots of ways to do this, but George Polya's four-step process pretty much says it all. Understand the problem, that means read, reread, read again, devise a plan, think about it, carry out the plan, solve the problem, and then check your answer. And so we don't have a lot of formulas in here. We will have some, but primarily we're going to understand the concept other than memorize formula, and everything we do, we have a cheat sheet. So you don't have to memorize any formulas. But there's some basic things we want to remember. Drawing a picture, making a list, guess and check, PEMDAS, right? Parentheses, exponent, multiplication, division, addition, subtraction, and solving an easier problem. So Jenny's model train is set up on a circular track. There are 6 telephone poles evenly spaced out around the track. It takes the engine of her train 10 seconds to go from the first pole to the third pole. How long will it take to go the entire distance around the track? So this is kind of a generic idea of drawing a picture. And if this takes 10 seconds, then that would take 10 seconds. And that would take 10 seconds to go around all 6 poles. So it would take 30 seconds. And we're going to look at a lot of examples here in this first section, just to get an idea of various types of problems we'll be dealing with. A rectangle has an area of 120 square centimeters. Its length and width are whole numbers. What are the possibilities for the length and which possibility gives the smallest perimeter? So this is a big one for an example of making a list. And if we have whole numbers, we can basically just start by guessing a lot of the values. So if the length is 1, that means the width has to be 120 in order to make a 120, okay, and this is centimeters squared area, which means the perimeter is centimeters. And the perimeter is about adding up all the sides. And since this is a rectangle, we have 2 lengths and 2 widths, which means it's 2 plus 240, right? That is 1 plus 1 plus 120 plus 120, which gives us 242. And we can go down and we can keep checking this. Okay, so let's see. All this has to be 120. We know that our area is 120. And so our whole idea is to basically guess these. And we can make the list. Okay, so 2 times 60, and same concept. So let's see, this is 120 plus 4, 124. And we know at this point, I could keep guessing those, but basically I need to skip down. And so let's try 8. So 8 times 15 makes 120. And then now we have a perimeter of 46, right? We're looking for the smallest perimeter. So let's see, how about 10 times 12 makes 120? And that would give us a perimeter of 44 centimeters. And we have found the smallest one because basically you want these numbers to be as close as possible. Now, I could have done this algebraically as well, but by making a list, I was like, that's definitely one approach. This is also kind of what we call guess and check. It doesn't really matter if you use algebra, that's great. If you use guess and check, that's fine too. The biggest problem with guess and check is whenever we have decimals. It's a lot harder to guess and check decimals, but if the values are integers, and this one straight out said they are whole numbers, then guess and check might be faster than the algebra. All right, Dan has twice as much money in nickels as he does in quarters. He has 33 coins in all nickels and quarters. How much money does he have? And so twice as much money in nickels, right? So 5 nickels equals 1/4. And so he has twice as much money. So he has 10 nickels for each 1/4. And this is another kind of example of I can kind of guess and check this. Right? So I see the pattern with 11. If I have 10 nickels and 1/4, that's 11 coins. And I could write the next, we might as well. I could have skipped down to 33 is my point there, but we might as well write it. This is another example of making systematic lists. He has 33 coins, all right? And how much money does he have? So that's basically 3 times 0.25 plus 30 times 0.05. And we already knew he had twice as much money, so that's 75 cents. And that one that would be $1.50, so that should be $2.25. And everything I do, I'm going to check in my calculator, and I highly recommend you to check these calculations as well. Because no matter how good we are with our math in our head, we all make mistakes. And so some things you're not going to see the calculation that I do, all right, because I'm just going to do it in the calculator. And also, I used to show calculator demonstrations, but the problem being that everyone has a different calculator, especially cell phone calculators. And this class doesn't have a standardized calculator. You can buy the TI-30 XS, or you can buy the TI-84, but I mean, you can get through this entire class with a $5 calculator. All right. On tests, I don't allow you to use your cell phone calculator, but basically on all lectures, activities, home funds, the project, feel free to use your cell phone calculator. As long as you making sure that you understand how to use it properly. That is just a big deal. All right. So these answers that I'm getting, make sure you're checking them in your calculator. So when you're running through a problem that you don't have an answer to, the calculation is being entered into your calculator correctly. Okay. Follow the instructions to see the trick. So choose a number. All right. I'm just going to choose the number, any number. So I'm going to choose 3. All right. Add 4 to the number. All right. Then multiply the sum you just found by 3. So then I multiply that by 3. Subtract 7. And divide the result by triple the original number. Okay, so the original number decrease the result by triple the original number. All right, so the original number is 3. That means that triple that was 3 times 3. So 14 minus 9 equals 5. Now, what's interesting is if you pick a different number, you will always end up with 5. And we can prove this with algebra. So if I choose any number let x equal a number, I can show that no matter what x is, you always end up with 5. All right, so add 4 to the number. That becomes x plus 4. Multiply the sum you just found by 3. All right, subtract. All right, and let's PEMDAS that, rainbow that in. That becomes 3x plus 12. Subtract 7. And then the last step, decrease the result by triple the original number. That means minus 3x. And oh, look. So no matter what number you put in there, you always get 5 out of it. So very, very interesting little trick. One person earns $48,000 a year. Another earns $37.50 per month. Who makes more money in a year and how much more? So this is all about the units, $48,000 per year. And since this is $37.50 per month, we need to get them into the same units. So I need to multiply this value by 12 months per 1 year. Which then gets us $45,000 per year. And so this is all about, again, reading the problem carefully, making sure your units match up when you compare things. All right. And so clearly, whatever, like person A here makes $3,000 per year more. And so again, reading carefully is a big, big deal when we're doing these problems. When we're doing all problems. All right, example. The local historical society wants to preserve 2 buildings. The total age of the buildings is 321 years. If one building is twice as old as the other, what are the ages of the 2 buildings? So lots of ways to do this. And really, regardless if you solve this via guess and check or algebra, you want to make sure you get your equations set up. And so I'm going to say x equals age of building 1, y equals age of building 2. And it doesn't really matter because we're just identifying both of them. So the total age of the 2 buildings, that means x plus y equals 321. All right, if one building, and it's not building 1, it's just one of the buildings, so it doesn't matter how I set this up. If one building, all right, so let's just call that y. So one building is means equals twice as old, 2 times. So that means y equals 2x, or x equals 2y. Again, it doesn't matter how you set that up. And so what are the ages of the 2 buildings? So we can do this algebraically, or we can do this with guess and check. And it's really whichever way you want to do it. I'm going to do it algebraically just to refresh us on this. And so this is the method of substitution. And we could guess these ages not pretty quickly. I can already see if the two buildings are over 300 years old. So if the one building is 100 years old, then the other building is about 200, and then I could figure out what that remaining value is. But the method of substitution says, put that value into here. So this gets me x plus, into this equation, I mean, specifically it goes in for the y, x plus 2x equals 321, because I'm replacing y with 2x. And that means that 3x equals 321 divide both sides by 3. That leaves X over there, and that leaves 107 years. And then Y equals 2 times 107, which is 214 years. And so again, that is a very easy algebraic solve, and that is a very easy guess and check. Doesn't really matter. Again, I'm not concerned with how you actually get your solutions. All right. Algebra is by far the most consistent way, because what we always have to watch out for are decimals. Example: Carlos has $9,000 in 2 mutual funds. One fund pays 11% interest and the other fund pays 8%. If his income from the 2 funds last year was $936, how much did he invest in each fund? So once again, X equals money in fund and money in, we can even be more specific, money in 11% fund. Y equals money in 8% fund. And so we start off and it says we have $9,000 in the 2 funds. So that means X plus Y equals $9,000. And then here's the tricky part. So one fund pays 11% interest, the other fund pays 8%, and the income off of those, which means the profit from only the interest, was $936, which means that I have 0.11x plus 0.08y equals $936. So we only get, all right, the money that is the profit, right? The actual, basically the interest made, all right? Money just accumulating money, all right? That's how investing works. And same thing as a note, I can solve this with guess and check, or I can solve this with algebra. I was like, we're going to do some algebra problems, but basically, if you solve this down, you will see that we have $7,200 in the 11% fund and $1,800 in the 8% fund. And the details, that's only the part of the problem, all right? You can review your algebra, and we're going to talk more about like solving algebraic problems later. But a lot of times, I mean, people can guess and check this. I mean, it's whatever, whether you prefer algebra or guess and check, that's absolutely up to you. All right. Well, you have yourself a wonderful day.